multi-tiered web applications, the standard way of producing web applications today. We will take the front end functionality. You'll often hear the term front end. You're probably familiar with that. That the front end computer, it runs a specific set of code that is responsible for handling, displaying web pages to the user, rendering things that the user needs to see, providing access to end user files, like image files that need to load on the page, things like that. That's all part of your front end infrastructure, right? But then there's the data side. So instead of building that data handling component of the application into the same server and code base that runs all the front end code, we separate that and install it on a completely separate computer. We use a completely different set of tools, and we connect to that computer's database through a protocol over the internet, right? So we'll run a MySQL server. That's where the LAMP stack comes from, or the WAMP stack comes from, where you're running Linux, Apache. Apache is going to be your front end service. It's what's responsible for serving HTTP content to your users. Then you tell your application through Apache, you tell your application that's running on Apache how to talk to a MySQL server, which lives on a completely separate computer somewhere out there on the internet. And you give it the credentials it needs to log into that thing, and it can start making changes to the database, storing user data in it, storing credit card information, whatever your web application is doing, whatever information it's gathering from your users, it can store in that database. And that's a separate tier in the application. So there's two tiers there. And sometimes there's a middle tier where data manipulation occurs. The web front end just collects data from the user when they need to input data, and it serves content to the user. And when it collects data, it passes it off to a middle tier, often called middleware. And that tier handles the manipulation of the data and changing state of things. And then that tier talks to the database tier and stores data it needs to store, retrieves data when it needs to retrieve it. So that's a 3-tier solution, right? Well,
so a 2-tier, meaning the front end and the back end, they are stored in a separate server.
Yes, they're in separate servers, and they all listen on certain ports. So do you know about starting web services and listening for connections on certain ports? It's server-client communication.
In Windows, I've just used maybe ping only.
So let's talk through it. So when we're running an Apache server, it's listening typically on port 443 if you're using SSL, or port 80. So when you run an Apache server, whether it's on your laptop or on a server somewhere in the cloud, or on a computer that you have under the desk, what it does is it comes online on that computer, and it takes control of one of the ports and says, I'm going to accept connections on the port that I'm configured to accept on. By default, we use port 80 for unencrypted connections and port 443 for SSL encrypted connections. Now, when we use our web browser and browse to the web address or the IP address or the DNS name, if there is one configured, of that computer, and we connect to port 443, we say, hey, is there an Apache server listening? Or is there an HTTP server listening? Because Apache is just one type. And it says, yes, I'm listening, and here's a response. And that's when you get that like 200 OK response back. Now, we talk about multi-tier applications a lot, but more these days we talk about microservice applications, especially in kind of the virtual computing space that I occupy. Microservice architectures are kind of the ultimate multi-tier architectures. They have more than 3 tiers. They have many, many tiers. They have many different components all talking together, each running on their own compute services, whether it's a server or what we call containers. First, I'm going to show you a little bit about AWS.
Okay.
So this is where you go to log in. It's aws.amazon.com, which is a little weird if you are used to going to Amazon. So I have several accounts. I have 2 accounts right now. Okay. So this is what they call the AWS Management Console, as you can see. There's kind of a lot going on here. There's a lot you can do. It looks very simple, but there's a lot of different stuff. AWS provides its cloud services in various groups. And these are all the services it provides. Each of these is a unique, independent service that each of them can take a long time to get good with, right? But there are a few core services that we work with that everyone using AWS kind of works with. These are the big ones that employers want you to know right now. There's VPC, there's EC2, there's SES, Simple Email Service, there's SQS, Simple Queue Service. EC2 stands for Elastic Compute Cloud, and VPC stands for Virtual Private Cloud. Actually, Elastic Compute something. I might not be sure what EC2 stands for anymore, but it's where the computers come from. There's also Lambda. A lot of employers want you to know Lambda. That's what we call serverless technologies. Elastic Beanstalk is pretty popular among developers, but typically they don't need operators to help them run Elastic Beanstalk. EBS is part of EC2, Elastic Block Storage. It's kind of its own service in a lot of ways, but it is part of the EC2 service offering. It is where you can create virtual hard drives and make snapshots of them and clone them and do various things with hard disks. I might be missing some that are like the key components. There's plenty of other ones that are very popular right now. EKS is a Kubernetes service, which is container orchestration. I don't want to get too deep into the weeds here because it can be very overwhelming, the amount of different things here. I don't know what most of this does, and I've been using this stuff for years. But there's some cool ones. Like I use Workmail, for example. So I have email boxes. I have mailboxes for magesguild.io, and I have mailboxes for talosthorin.com. I keep the magesguild.io stuff here. I have a personal AWS account that I keep the Talos Thorin stuff in. I added an organization, gave it a name. I have to own this domain name, and I have to set up DNS entries. Oh, Route 53 is one of the big core ones. It's the DNS servers. But I have to be able to prove with DNS that I own this domain, which I was able to do. And I went in there and I created a couple users. So I have this service account user, and a service account, when you create a service account and give it an email address like this, what that means is it's an email, it's a user in my system that has administrative or non-administrative privileges depending on how you're going to use it, that is non-human. It's not a person, but it can receive emails as though it's a person. The mailbox of it can be used by multiple administrative users in your organization in order to respond to requests that need to be handled by the organization. So you make service accounts to help automate things and help prevent services that your company uses from being tied to an individual who might quit or leave or pass away unexpectedly, and then suddenly nobody can like get into things because they don't have their passwords. So I have a service account here and I have my account, and all this did was it in the background, AWS created for me a Microsoft Exchange mail server and configured it securely and just made the mailboxes for me. So I didn't have to go create a mail server, configure it, configure SES, Simple Email Service, which is required to send emails from a VPC. It's kind of a complex requirement. There's a lot of configuration and maintenance that I don't have to do. Also, I gain the benefit of emails I send from my mailbox, from my domain, have a good trusted reputation based on where they're coming from, because Amazon has a good reputation, and I get a lot of benefits with this. It's very easy to set up, and boom, I got my own email, my own mail domain. Route 53, let's look at that for a moment. That's just a fun one, right? Like, it helps me have personalized mailboxes. They're not just Gmail. They're not just, you know, yahoo.com or whatever. Like, it's my domain, and people see that.
Oh.
And so here, do you know much about DNS yet? Have you guys covered it?
No, not really.
So domain name service, we'll just do a light introduction to it. It is how the web browser knows how to translate google.com to the IP addresses that google.com ends up resolving to. When you type a request into your browser and you say, you know, I want to go to Amazon.com, I want to go to aws.amazon.com. Your web browser first sends a DNS request to the internet. And there's many, many DNS servers out there. It's a global network of servers that are specifically storing DNS information. And you have to go and configure your DNS information and allow that information to propagate across this global network of servers so that everyone in the internet across the world is able to go to your domain name and know how to actually route to the correct IP address that your web services live on, right? So DNS is very important for just the basic functionality of the internet. When I set this website up, I had to first register a domain. I had to pay for this domain. I have to pay for it yearly. So it's not very expensive, but it is a yearly cost that I have to pay. This .io or .com or .org, those are the top level domains. You'll see the term TLD, top level domain, a lot. That just means the very last part of the domain name. Everything in the .com domain space is part of that top level domain, right? When you think of magesguild.io, you can think of Mages Guild as a subdomain of the IO top level domain. Just like I could create chat.magesguild.io, and chat would be a subdomain of magesguild.io. So you can think of it that way. These ones, though, these are the name servers entries, and these are the DNS servers that are the authoritative name servers. So the name servers, when I talked about the global network of DNS servers out there, all those servers are called name servers. When I created this record set, it gave me a set of name servers that AWS controls. The point is, right now, this particular record, which is a name server record, when I do a DNS lookup, which I can do with the dig tool. So there's a tool called dig. This tool allows us to make DNS requests to any DNS server in the world. We can specify a very specific DNS server if we want to, or we can let it just find the nearest one. And we can ask for various name service records. So I can say, what is the name server record? So I'm digging, I'm looking for the name server record. This just happens to be the syntax for doing that for magesguild.io. And you can see it gave me back the same name servers that we have set here.
Yeah.
So any computer in the world that wants to know my DNS records can just request them. And that's how your web client is able to find stuff on the internet. So we spent a lot longer on DNS than I meant to because I got a little babbly.
VPC.
VPC, so it stands for Virtual Private Cloud. And what VPC allows you to do is create whole networks that are completely virtual. When you're on your private network, when you connect to your Wi-Fi, you probably get an IP address that looks like 192.168. So that .1 is the address of the router itself. But if you notice, it's just one address in an entire network space that router provides. That router probably provides 256 addresses, some of which are defaulted to be used by certain things, including the router itself. But there's 256 addresses between that .1 and .255 that actually the .0 and .255 that are free for the taking. And when you connect to the router, The router, the DHCP service on that router, gives one of those IP addresses to your device, and your device gains that address on your local network. So you might see that your device has a different IP address, and I can look at that on mine, but you can see this is my current IP address on my network. The router that I have, it provides a 10 dot address space. The point is that you can create a network like this with VPC and start attaching devices to it and handing out IP addresses within that local network. So if I go here, you'll see that there's a default VPC. I keep putting the video in my way. Actually, this is the default VPC. Oh, we need to cover some basics. AWS has multiple regions. Each of these regions is in a different place in the world, and each of these regions has multiple availability zones, or AZs. Availability zones are themselves in different locations in the world. So I'm using US West 2, which is in the state of Oregon, and in US West 2, there are 3 or 4 data centers, physical buildings full of computers that actually run all this stuff on the background. And each of those data centers represents an availability zone. So AWS has this unique ability, not so unique these days, but unique when it came out, to build one single network that spans multiple availability zones. So you can build this one network that actually physically lives in multiple different physical data centers in the world, as long as they're within the same region. They'll be in the same state as one another, but what this does is it allows for something called high availability deployments, where you can create a cluster of computers living behind a load balancer, which distributes traffic to those computers. And each of the systems in that load balancer group will live in a different availability zone. So if one of those data centers that represents an availability zone fails in some way, if it catches fire and the machines die, if electricity goes out and the machines die, if a flood happens and they can't keep it running, if some disaster happens that causes that whole data center to stop operating, you still have 2 whole data centers that are potentially fine, and those machines live on. So what happens is this data center, the machine living in it, fails because it's failing. It goes unhealthy behind a load balancer. The load balancer stops attempting to send traffic to it, and it just sends traffic to these 2 machines instead. And that allows users of your website they might experience an error, but when they reload, the website's still there and they can still use it, right? So that's what high availability is. It means that the website never goes offline. People can always rely on it to be there. It's important to know, when you're using AWS, you have to deploy to a VPC. There are very old accounts out there that don't have to live by that rule. When you create new machines, when you create new services that are tied to a network, they have to be associated with networks living inside of a VPC. In a VPC, there are multiple components. We have subnets, just like we can create subnets on our own home networks. We can create subnets here. And we describe these subnets with something called CIDR ranges. There's going to be a little bit of homework from this one. You're going to have to get familiar with how to use CIDR ranges. So here you see I have multiple subnets. Let's look at one of them in detail. This little control lets you change how much you can view. This is the details of the thing I just selected, which is this particular subnet. You can name it. You can give it meaningful names. You can give them tags. Tags are very powerful in AWS, but that's a topic for later. But you can see it's got a very specific generated ID. It lives in this VPC, which is a very specific generated ID. This is something we'll cover later. It's more advanced. Route tables are important, but we'll cover that later. You can look at the route table here. It defines a couple of routes to the public internet, from the public internet. So we can configure subnets in different ways. They can be exposed to the public internet where people can get to the machines that live in your VPC from the public internet, and they can be private, where you have to be on the private network in order to access the machines. And there's actually very specific ways that you're supposed to build these VPCs so that you have non-sensitive data living in public subnets, but they talk to machines that live in private subnets to access sensitive data when they need it. And that's advanced stuff. We won't cover that today. All of this stuff is important to get familiar with, but we won't go into detail on those. Let's talk about EC2. This is the meat and potatoes that I wanted to cover today. When we're talking about deploying services to the internet using AWS, there are many ways to do it. Lambda is a very popular way to do it without ever having to touch EC2. That's advanced stuff. We'll cover that later. I'm not very good with that stuff myself, but we're usually talking about, in one form or another, creating or spinning up new instances of EC2 instances, which are themselves virtual machines. Right now, you can see I have no instances running in this particular region. If I wanted to create an instance, I just can click launch instance, and boom, I have all this stuff to choose from. Amazon Linux is probably my favorite. I haven't had a lot of time to play with Amazon Linux 2. These are Linux distributions. They have a Yum package manager like CentOS or Red Hat, and they are built specifically for use on AWS. These are created and distributed by Amazon themselves, by the AWS teams, and they are very good operating systems. I love using them, but I don't get to use them much these days. I mostly work with Ubuntu server. You can see here we have 1804 available. We have plenty of other servers available. Red Hat, this comes with a license fee. Now, the good thing is if an organization wants to use Red Hat and wants the support that comes with Red Hat, which a lot of corporations do, the licensing is built into this. And the same is true for Windows servers. So it's a little more expensive, but it tells you how much it's going to cost up front. You only have to pay by the hour. In fact, you only have to pay by the second for these ones. And so if you shut it off, you only pay for exactly as many seconds as you use that machine. You can just spin up these instances, use them for as long as you need them, pay for what you use. And there's specialized ones. You can see, okay, this one it's Ubuntu, but it's called deep learning based. So it has special software pre-configured on it for people who need to do very specialized computer AI learning type of stuff. We're going to go ahead and grab an Ubuntu 1804 machine. Now you'll notice this is new. There are this AMI. I often call them AMIs. Many of us often call them AMIs. AMI stands for Amazon Machine Image. This ID is a unique ID that represents an image from which you can create new instances. And these are your base images. Whatever's in here will always be in whatever you spin up with it, right? These AMIs rotate. So as Amazon, releases new updated base images that have the latest installs in them, these AMI IDs will change. And it's actually kind of a big problem to solve to keep track of these things. A lot of people write Lambda functions.
So what's the difference between the x86 and the ARM?
So ARM processors are much less resource intensive. They have a much smaller instruction set. I believe, I may be thinking of RISC, which is a different architecture. I think ARM probably has a smaller instruction set than x86, but there's some key differences. For the most part, the software we're going to work with, we want to be running on x86 infrastructure. There are some of the differences are that not all software supports both. Not all software is going to be running on ARM. When it does, it's not always going to be the most up-to-date version of it. That's an important distinction here. If all other things being equal, if the software were 100% supported the same amount that it is on x86, we could choose either of these and run sufficiently. I think an x86 might be a little more performant than an ARM in certain situations, but the reverse is probably also true. So we're going to select it and we're going to run it. Now, there's a lot of a lot to configure here. You have to tell it where it's going to live. You have to tell it what it's going to be. Instance types are how you understand different hardware loadouts for these instances, right? They're virtual machines, so they don't technically have hardware loadouts, but they are using specific types of hardware on their backends. Different instance types may be using different types of host servers with different types of hardware to make them better at this particular thing or that particular thing. And on top of it, more or less resources will be allocated for different type sizes, right? So, and there's a lot to unpack here. We're not going to get too deep into it. These are the big dogs. If you're running big services, if you're running production services that serve a lot of traffic, you are at least using M4s. There's also R4s and C5s and blah, blah, blah. All of these different letter number combinations before the dot, however sized, are different types of machines tuned for different types of use cases. For the most part, we use M4s for production services, and we use R3s or R4s for database services. I'm not going to get into the details of why, mostly because I'd have to research them more to tell you, and time. But we're going to go ahead and grab us a T2 medium. We want 2 and we want 4 gigs of RAM. So that's a pretty decent machine to start with. We could just do review and launch right now, but we want to configure more. We only want one machine, right? So you can see there's a lot. This is just one of the configuration pages we're going to step through. We need to assign it to a network, and that network needs to be inside of VPC. We can let it land on any of the networks inside the VPC that it wants to land on, or we can choose a specific network. Now you'll notice this US West 2A, US West 2B. We're in the Oregon region, which is also known as US West 2. This is US West 1. Each of these regions has a unique identifier. This is EU Central, I think. EU Central 1, I think is what that one is. I don't use the ones overseas a lot, but they each have their own identifier. And within the region, each of these letters represents an availability zone. So as I was talking about earlier, we can set up these networks so that they have subnets in different data centers in the world. And each of these A, B, C, D, there's 4 of them here that we can land them in. Now, we don't really know exactly where those data centers live. AWS does not publish that, like the addresses of those buildings, because to protect them, but we do know that they live in Oregon.
And can I ask a question?
Yes.
What is the work of the subnet? Because I just see the word subnet in networking, subnet, but I've not really known what's the use of it.
So when we create a network, we have a certain amount of address space to work with. We have a range of numbers we can hand out. And within that range of numbers, we can say, hey, you know what, take this chunk of numbers and make that chunk of numbers dedicated to its own space. It is itself an address space that we can hand out IP addresses from, and it is partitioned from the rest of the network. Taking one network and separating it into multiple separate networks. And you can build routes between them, but they're each their own compartmentalized address space. For the most part, we just need to understand that each of these subnets is its own unique location in the world. There's a certain amount of IP addresses in the subnet that can be handed out to various devices, and that these subnets currently are able to talk to one another by virtue of route tables that have been set up. This is the default VPC that any AWS account in every region will provide. And we can just deploy services there for testing, and that's what we're going to do. So we do want to assign a public IP address. Now, when we spin up this instance, we can spin it up with or without a public IP address, regardless of whether it lives in a public network. Thank you. Right now, we want to be able to reach it from the public internet so we can log into it. So we're going to do that. There are various secure ways to do it where you set up what's called a bastion or a jump box, and everybody logs in through this machine, And this machine it's the only one with a public IP address, which you can like attach and disattach depending on when you want access to it. And then this machine, you SSH into other machines behind the network. But we're not going to worry about that. We're just going to connect directly to this guy. And then this is not something we want to change.
You know, I think the more you explain, the more I'm getting the picture of how people, you know, hijack some networks, you know, how the hackers work.
Yeah, there's a lot of different ways that networks can be attacked, and there's a lot of different ways that you have to secure and harden them against attack if you want to stay safe. And fortunately, AWS makes it very easy to do those things. There's a lot of stuff that you can do with standard networking equipment if you have direct access to your own networking equipment that you could never do with AWS. But there's a lot of things that AWS does for you that help secure, and there are a lot of certain what they call best practices, ways that you should design to use AWS, that when you follow those best practices correctly, and you often have to tweak them for your needs, but when you follow them correctly and tweak them correctly for your needs, they end up giving you a very secure deployment if you just follow their instructions. So it's a lot to learn, but once you learn it, this tool set is incredibly secure, this whole platform. So we normally would assign it an IAM role here. I don't have an IAM role created for this. IAM is another one of the core services that I probably didn't mention. It stands for Identity and Access Management. It's how you provision users to be able to interact with not only AWS itself, but AWS resources that you control. Right now, we're not going to worry about that. It used to be that when you created an EC2 instance, you either attached an IAM role to it right away, or you could never attach an IAM role to it. So we always wanted to make sure to attach one. But lately, it looks like you can attach them even after they've created. So we're not going to worry about that right now. Shutdown. When you create one of these, you can tell it, if you want it to be super temporary, go run some jobs, turn off, and go away, right? You can tell it shutdown behavior terminate, so that when the computer turns off, it destroys itself. We don't want that here. We want it to just turn off so that we can restart it if we want to. Enable termination protection. Let's do that. This prevents somebody from just going in and accidentally destroying the machine, because you could just destroy them. They go away forever. If somebody tries to, it'll be like termination protection is turned on. You need to go turn that off first. And they'll have to have permission to turn it off in order to do so. Enable CloudWatch monitoring. We're going to cover that, so we want to go ahead and do that. It costs a little extra. This is not the page I need, but we're going to do that because we want to cover that topic. Although I think we can enable it later. Yeah, let's just let it go. Elastic inference. I don't know what this is. This is new. Provides cost-efficient hardware acceleration for deep. Oh, I don't need that. Enable allows. No, I don't need that either. Okay. Network interface. We're just going to let this build a network interface. We don't need to add any additional. We don't need to assign it an IP address, but you could say on this network interface, I want this very specific private IP address from the subnet. We do that at work. I want to move away from it. You don't usually want to do that. It's kind of bad practice. So now it's gonna, I feel like I missed something. Yeah, I missed something. So I accidentally clicked review and launch, which I do often. So we skipped a bunch of stuff. So we're done here. We want to add storage. Now, if you can just click review and launch and it'll do some stuff automatically for you, but I don't like to let it do that. You can, when you're playing with this on your own, you can totally do that. But for me, I don't like it because it creates some wizard things that end up kind of cluttering the environment. We want a 10 gig SSD. Let's go with 20 gig SSD. Let's go with 30. So this is not part of EC2 so much. What this is going to do is it's going to create an EBS, Elastic Block Storage Volume, for us, and it's going to attach it to the instance as it creates it, and it's going to install the operating system there. And then we can add tags. I like to add a name tag. You can create any kind of, you can create any kind of tag that you want. You can give it any kind of key value that you want, and you can give it any kind of value that you want. When we create a name tag, it will show up as a name in the name field on our console output. Let's call it Kizito's. All right. And then security groups. Security groups are extremely important. They're a part of the EC2 and VPC in some way, although we mostly use EC2 security groups. They're part of the EC2 service. You configure them to allow certain connections. It's basically your firewall. If you're familiar with firewalls, this is your firewall. If you're not familiar with firewalls, this is still your firewall. It's what allows you to define rules that say people from this address, whether it's the public internet or a private network somewhere out there, people from this range of IP addresses or this one specific IP address have permission to reach this particular port within my network. And you can do a lot with it here. We want to allow SSH access because we're going to try and SSH into it. We want to be able to SSH into it from anywhere. SSH is port 22. I can't change this right now because it knows SSH is port 22. And we can give it a description if we want. Mobile SSH. We don't want to let it create a new security group. Actually, if we did, we would want to change this. When I see Launch Wizard sitting around in my AWS accounts, I get annoyed that somebody did that. So I like to use an existing one. There happens to be a default one associated with the VPC, and I'm going to go ahead and use it. Right now, it allows all traffic from everywhere. This is a very insecure security group rule. This is one of the most insecure security group rules we can use, but we're not doing anything mission critical here, so we're going to go ahead and use it. Defining secure route tables, secure security groups, secure ACLs, access control lists, which is something I don't use often. These are in themselves things that take a long time to become expert at, but we don't have to worry about it right now. We just have to know that they're necessary to operate. So we're ready to launch. We can review all the stuff we changed, but I know we did all right. No existing key pair. So this is a problem. We have to have a key pair in order to launch. So I'm going to go ahead and create one of those. Now, what this is our SSH key pair. We cannot just SSH into this machine and use a password. They simply don't allow it. What we have to do instead is create and register an SSH key pair, network and security. So you can create a key pair here, and when you do that, you give it a name, and it'll give you the private key that you need. You have to get that private key, and you have to install it correctly on your workstation in order to use it. I don't like to do that. I like to import my key pairs because I've been creating key pairs for a long, long time, and I just do that. So I actually have some key pairs here. I'm in my home directory. Remember, I'm on Mac, so it's users instead of home, but it's the same structure underneath my directory. So you'll see I have plenty of stuff here. I want to look at my hidden SSH directory. Remember, this dot means it's hidden. It's there. It doesn't show up by default. I have a bunch of keys here.
And before you continue, what's SSH in full?
SSH is Secure Shell, is what it stands for. And it is what gives you an encrypted connection to a bash session or other shell that you've defined. You have to define it server side if you want to use something different. In Ubuntu, we're actually using a language called Dash, but Dash is 100% backwards compatible with Bash, and so they just alias it to Bash as well. So I have some keys here. you can see that every key file I have is a pair. There's a regular one and there's a .pub one. The .pub pair, part of the pair needs to be published to wherever you're going to use it, whatever you're going to SSH into. And you can use these for more than just SSH. These key pairs are very versatile. I don't presently have one for this AWS account, so I'll go ahead and create one. To do that, I use the keygen command. Now, I like to give it some flags, and let's take a look at those. There's a lot of flags, but they're not very well defined, or they're not really described very well here. I use the C flag, capital C flag, to give it a comment that just puts a little descriptive thing in there that lets me know a little more about the key when I'm looking right at it. I like to tell it the exact amount of bytes, and I use 4096 always, except in very specific cases where it's not supported. This is the length of the key. 2048 is very, very common. It's the most common, but 4096 it's more cryptographically secure. Some algorithms have been known to be breakable even at 4096 when certain flaws have been found, but at that point, there's nothing you can do. And I like to use, I like to give it a specific name. So I do SSH keygen. This is the comment I want stored in the both versions of the key. I think the public key, actually, I want it to be 496 bits long. I want it to be, and it has to be a power of 2. I want it to live here in this directory, and I want it to be called okay, so I hit enter. It asks me for a passphrase. Now, usually what you want to do in traditional systems administration is create a passphrase here. If you're working with production systems, you want a passphrase here. I'm not going to put one. So when you do a passphrase, what that means is the local private key itself is encrypted, and it uses that passphrase to decrypt it. So you can't actually use the private key until you decrypt it. When you need to do that, you can use a tool called SSH add and tell it SSH and my key, right? Oh, I'm already in that directory. And it'll add it to what's called the SSH agent, which is itself a topic to study. When you do that and it has a passphrase, you give it the passphrase, the SSH agent will unlock it, hold it in memory, and let you use it throughout the day. Otherwise, every time you SSH, you have to give it that passphrase. But right now, we're practicing, and this key is not critical. I don't need to protect it that much. My hard drive is encrypted, so it'll be fine when my computer's turned off. The risk, though, is someone could steal it when your computer's turned on if they compromise your machine. And if it has a passphrase, they can steal the key and still not use it. So that's an important thing to remember. Although frequently when we're automating things, when one system needs to SSH into another system automatically without human intervention, we very much do not want a passphrase on these keys. So that's there. You end up with these schemes and tools where you're constantly rotating those keys. Every 30 days, you generate a new one, decommission the old one, and continue operation instead of using a passphrase. That keeps it secure. But for now, we're not going to use a passphrase. We just want to SSH right into it. And in order to import the key, all we have to do is upload the public key. So I'm going to cat out the contents of the public key. And the public key is to be shared, right? So what people can do is, if you sign something, if you cryptographically sign something with your private key, the public key can be used to decrypt the thing that you signed with your private key. So people with your public key, you give it to everybody, and those people can verify that things belong to you or originated with you, or that you are who you say you are in this case, because they know that that you are the only person in the world who has a copy of your private key, as long as you keep it secure. And they know that only that private key can sign things that this public key can decrypt. It also works in the reverse. People can sign things with your public key that only your private key can decrypt. And then that way they can encrypt things and send them to you that only you can receive. That's actually how the PGP keys work that drive Keybase. That's how we get end-to-end encryption. I'm just going to copy this content and paste it over here. I'm going to give it a key pair name. I usually do this as the comment. I try to do username at the device I'm connecting from. And I like to keep different key pairs for each device that I work from, which I try to keep to a maximum of two or three. And this device happens to be named Guildmaster. So I'm going to import that key. Now, scoot. If I go back over here, and close this out, you can see we still are in a state where we can launch. Let's launch it. Well, now we have a key pair we can choose. We have to verify before it will let us that, yes, we can get into this key. This is mainly so that people can't call them up and be like, you broke my box. And they're like, well, you didn't have a key pair. You're not going to be able to log into it, right? So, boom, it just starts spinning up the instance. Tells us a little information here. I don't think I've ever once read this. It's not important. I mean, it can be, but I know what it's doing. So we see your machine spinning right up. Now it's in pending. It's going to take a little bit. We can examine some of the details of it. Status checks aren't checking yet. That tells us whether the machine's healthy. There's dashboards here. Once it starts running, we can see dashboards about, CPU, disk reads, so you can get a lot of detail about the health of the machine here, how it's running, how much traffic it's accepting. This little button here refreshes just that, so that you don't have to go up here and refresh the whole tab all the time. This little button here does the same. And then it's up and running. So now we can try and log into this machine. First, before we go doing that, we need to know the address of the machine. Remember, we didn't assign it any specific IP. Now, it's important to know that there are multiple ways to assign a public IP address to an EC2 instance. There's something called elastic IP addresses. They cost money in and of themselves. They are permanent, and they are detachable and reattachable. You can assign them to a machine. You can unassign them from a machine. You can assign them to a different machine later if you want to. Those are very important for long-term machines that need to have a static IP for a long time. But we didn't do that here. What we did was we just allowed it to assign a public IP that was available. Now, this IP address is non-static. It will change over time. And because the host name is based on the IP address, this host name might not stay the same all the time. So it's important to know that this IP address is going to change. Now, we can use DNS tricks to give this machine a host name that we can always connect to, and we'll cover that, but probably not today. This is the private IP address of the machine. This will never change. Once this machine is spun up, it has this IP address for its entire lifespan. You might be able to do things to force it to change. This little thing lets you copy. It's very useful. This little symbol here. So we're going to go ahead and copy the public IP address and see if we can log into it with our current key. Now, these machines come up with a default administrative user, and for that administrative user, it installs the public key that you provide when you select a key pair. And that means I need to know the administrative user's name. Now, for Amazon Linux, the user's name happens to be EC2-user. For Ubuntu, it's just Ubuntu is the username. For CentOS, it's just CentOS is the username. There might be others out there. Those are the three big ones that you need to be sure. If you're using multiple deployments, multiple distributions across multiple deployments, it's important to know that sometimes you will experience login failures because you used the wrong username, and you just need to change that. But for now, we only use Ubuntu, so it should be easy to remember. We want to paste that, and then because I haven't done any configuration to let it know otherwise, I need to tell it which key to use.
And can I ask a question?
Yes.
Is this the same way that you can set up maybe one machine in your home so that you can just be logging into that machine, do your stuff and log out without even, touching the machine?
Yes, very much so. That's how I administrate my my home server, my virtualizer. It doesn't have any computers plugged into it. I just SSH into it. Now, I'm not getting through to this machine for some reason. I should be able to get to it. I should have logged in by now. So something's wrong with our configuration. Let's take a look and figure it out. So most commonly, the issue is that the inbound rules don't allow anything. But this says we're allowing all ports on all to the complete, the entire internet. Everybody on the internet can get to this machine on any port. So I'm going to go ahead and examine this machine. I'm going to scan its port 22. Now, this is something you can do from your workstation, but when you're working within a VPC, you don't want to do this. It's against the rules. You have to get special permission to do it. And if you do it too much, they will freeze your account, stopping all your instances. So it's a big deal to remember not to do this when you're logged into a VPC or an EC2 instance and you're trying to troubleshoot network connectivity to other EC2 instances. But I use Nmap to scan ports very frequently from my workstation. Filtered. For some reason, it's filtered. So we're not going to be getting to that machine on port 22 without opening the port somehow. Well, that's much cleaner than your Windows desktop.
Oh. So I should fire up the terminal, right?
Yes.
Okay. There you go.
Do an ls on the .ssh directory.
.ls?
.ssh right there. Just dot. Like no slash between the dot and. It's a little confusing because it's almost like you're trying to say, so you don't have one right now. So we'll have to create one. So if you just do a make dir and then that same directory name. There you go. Now we want to do an LSLA. So press up twice. And then do space and then do -LA. Or list format with permissions and show all, including hidden directories. There you go. So you see, you're looking inside of that directory. So it's telling you the permissions of dot and dot dot, which you see that the permissions of dot is the permissions of that directory itself. The dot, and we need to change that or else it's not a secure directory. So we need to change it from what it is now, I think is 755. Yeah. And we need to change it to 700. Do you know about chmod and octal format and what these permissions are on the very left here?
This I just know of. R is read, W write, then X I'm not sure.
Is execute. So very good, by the way. So the D, it's telling us it's a directory, I guess. I don't actually know the exact meaning of that. I'm pretty sure it just means directory. And then the thing is, so there's three groups of this RWX, right? Each of these groups corresponds to whether it's the user that has permission, the group that has permission, or other, meaning any other user on the system that has permission. So what this says is right now, the user has permission to read, write, and execute on this directory. The group has permission to read and execute on this directory. The anybody else on the system has permission to read and execute on this directory. Now, you can see the owner, the user owner and the group owner. You can see that young coder, the user, owns it, and young coder, the group, owns it. If you wanted multiple people to own this, it might be owned by a different group, like users or something like that, because there's a group on the system called users. But we want it to belong only to you, and we want only you to be able to look at the contents of it. So we need to change the permissions of it. And the way that you do that is by using the chmod command. So yeah, there you go. And then the permissions we want is for the user to have read, write, execute, and for nobody else to have any other permissions. So in order to do that, we use the number 700. Now, the reason that we use the number 700 is because it's a bit mask, much like with the IP addresses, there's a bit mask involved. So what we're saying right now is that we have 3 numbers here, and each of these numbers corresponds to these little groups of RWX. The R itself is represented by a 4. The W is represented by a 2. And the X is represented by a 1. So whatever permission set you want to grant, you can grant by adding those numbers together. So if you want read write only, the number's going to be 2 plus 4, read plus write, and so it's going to be 6, right? For a directory, we need execute because we want to read it, we want to write to it, but we also want to be able to enter it. We want to be able to change directories into it. And for a directory, it happens to need the execute flag. So you need to change that directory to 700. So now do space and then do .ssh to tell it, I'm changing the directory. I don't remember what change mod stands for. Yeah, there you go. Now just hit enter. Now if you press up twice and hit enter again to do the ls command again, you see those permissions changed. That's secure, and when we go to SSH into servers, that matters because if the permissions aren't secure enough, they will simply reject our request to SSH in. So now we can, I like to change directories into that directory, but you don't have to. Instead, let's just do SSH-keygen, all one command.
Like that.
Exactly. And a way that you can confirm it is by attempting to use tab completion. So do me a favor and backspace a couple of characters right now. Right now, press the tab key. You see how it auto-completed for you? Tab completion is a very powerful tool, not just for saving yourself time typing, but also verifying that you're typing the correct command names. Because when an auto-completion is available for an existing command, if you're typing it wrong and you're pressing tab and it's beeping and booping at you and not completing it or offering you options because there's multiple matches, it means that you typed something wrong and you can catch that typo quickly by using tab completion. We're going to let it create a default key for you. So all we really need to tell it is the byte size because I do still want a 4096. So if you do -B,
-V,
B,
B.
Yeah, there you go. They sound very similar. And then space, and then 4096.
4096.
Correct. And then I think you can just hit enter from here. Let it go ahead and hit enter. That's where it's going to save the private key file to. And then give it an empty passphrase, just hit enter again. And then confirm that it's gonna be empty, there we go. So now you have your key. If you do, press up a few times until you see that LSLA. There you go, hit enter. And now you see that those keys are there. And you look at the permissions on the private key versus the public key. You can see that everybody can read the public key, but nobody can read the private key. Now, unless you share that public key, nobody if we had another user on this virtual machine system that you just created it on, no other user could see it by virtue of the permissions that you set on the directory that contains it, the .ssh directory. So now we have a shareable public key. And if you send me that public key in the Keybase chat, I can install it on the server, and I'll show you what that looks like.
So how do I get to that public key?
So you can just cat out the contents of it and make sure you do only the public key for this. Don't let it cat out the private key. So you just type ID and then just hit, oh no, do, sorry, .ssh/ID, because you're in one directory above it.
.ssh/ID.
And then hit tab right here. There you go. And then period, and then hit tab again.
What?
Hit period, the period key, and then hit tab again.
Oh,
boom, see that? That's cool, right? And now you can hit enter. So just copy that whole thing and paste it at me in Keybase. So on the server side, on this machine that you want to be able to log into, whether it's a server or a workstation that you want to log into from a remote location, or any SSH server that you're running that you want to be able to log into as a specific user, you install an authorized keys file, authorized_keys in that .ssh directory. This is a configurable part of the SSH server. You can tell it, you know, users authorized keys live in this other location or that location. But this is a good default, and most everybody just does this. It's what the default configuration is. So
maybe
what?
A PT update.
Did I accidentally? Well, this is a Red Hat machine.
Red Hat.
That explains that. I spun up the wrong instance type.
Oh.
So we're going to destroy this machine. It was my mistake. And we will spin up an Ubuntu box instead.
Yeah, sure.
For the sake of the recording, we corrected the issue, clicked around too much, ended up with Red Hat Enterprise Linux instead of Ubuntu. Now that we have Ubuntu, we can go ahead and complete what we were doing. We could have continued with RHEL, but I don't want to pay license fees for a proprietary support license and stuff. All right. And then let's also make sure Sage own. I'm using the user group ID because it's faster to type. Let's do, okay. Now you can attempt to log in. So from your Linux virtual machine, because we generated the default locations for the public key, that at .ssh ID_RSA and ID_RSA.pub, because that is the default key. So the system will attempt to use that key if it exists, just anytime you use SSH. So we shouldn't have to do any additional configuration. From your SSH on your virtual machine, you should be able to run the command like this: SSH Kizito at, and then this IP address.
Okay, let me try that. SSH Kizito. Yeah, it's there. It's showing me Kizito at IP, then the IP address, then the $sign.
All right. Well, you are logged into your first cloud instance. See if you can show me your Could you share your screen with me for a little bit? All right. So now you can do some stuff. Do me a favor and type sudo and then space.
Sudo.
And then which, WHICH. And then which again, space, and then which one more time. So we're asking, where is the which command? And we're using the which command to do that. But what we're testing here is, can I run it as a super user using the sudo command? So hit enter for me. It's asking for a password. So that's not going to work because your user doesn't have a password. I will make it so that you don't need a password.
Oh.
We're going to trust that if you can log in, you have a key. You don't have a password. Therefore, if you can log in, you have sudo privileges. So now try to run that command again. Just press up and run it again. There we go. So you have administrative privileges on this machine, and you can install packages, you can remove packages, you can tinker with software. And what I want to use this machine for is to start an Apache-based project. We're going to do a LAMP stack project. We're going to start with this one machine, and we're going to install and configure Apache. We're going to install and configure MySQL, and then we're going to build some kind of application on it, whether we deploy something that exists for practice or whether we want to build something from scratch. We can do both. So we're going to start with this machine as our full stack machine. And then along the way, we're going to spin up more instances. We're going to talk about standing up separate databases themselves. We're going to talk about RDS, a managed database service offered by Amazon, and we're probably going to start using RDS right away. We're going to do a little bit of practice with a separate database, but then we're going to switch to RDS right away for anything that we are seriously deploying. And then we are going to branch out from this one box into multi-tier architecture deployments and just discuss and demonstrate and practice that kind of deployment together. This is where we're going to stop. We did a lot today. This is going to be a good foundation. I think we had some takeaways, some action items. We need to spend some time learning about networking, specifically IP address spacing, how to define it, how to read it, how to use CIDR ranges, how to understand what the bit masks functionality, like how the bit mask affects the range of addresses available in any given IP address space.